Greetings, Earth enthusiasts. If you ever wondered about the incredible perspectives our planet has to offer from high above, you're in the right place. I am Dr. Clive Coetzee, and I'm thrilled to be your guide on this captivating journey into the world of remote sensing. Welcome. And please remember to like, subscribe to, and share this video. Thank you.
In our previous set of video tutorials, we looked at the dynamic world and specifically focusing on the land use land cover dynamics for my region of interest. And we've performed various analysis based on the dynamic world data set, which is underpinned by the Sentinel images, daytime images. So we're going to walk off or depart that part of the remote sensing journey, and we're going to be focusing on another very interesting data set that I use quite a bit as well, not necessarily regarding the content of it, but what you can do with it, the different estimates, calculations, methods, analyses, what you can perform on that data set. I'm not really very much interested in, the outcomes of it in terms of the information, but more playing around with the data set to see what is possible in Google Earth Engine. And, once you've established what you can do, you can potentially apply that methods, analysis, tools to other data sets. So that's what we're going to focus on the next part of our journey into remote sensing. And the data set that I'm talking about is this particular data set, the TerraClimate monthly climate and climatic water balances for global terrestrial surfaces data set or data product. And you can see why I've chosen this data set. It is because it's a long data set. I mean, it's from 1958 till present, so that gives you many years of data, and it's monthly data. So you have a very big data set here that you can do all sorts of, or apply all sorts of applications, etc. So it's a wonderful data set to work with in terms of playing around with Google Earth Engine more than the information content thereof. So you can go to your Google Engine, you can go to your data sets, and then you can simply just in the search button search for the TerraClimate. Just search for it, TerraClimate monthly. You want to use that one, you can use that one, but basically TerraClimate, and there it says TerraClimate monthly, etc. So you just click on it, will get you to the same one. Okay, so how did we get to this part? You just go to your Google Earth Engine and you select data sets. Okay, and in your data sets, now you can use data sets and search for that. If you're not sure for that, you can obviously go to browse by tag or view all data sets. Okay, because that is climate. So if you go to view all data sets, okay, there should be a button for climate. Or you can just, this is alphabetic, so you can just go to the Terra. So that would be quite open. You can search for it using this format, or you can just basically go to browse by tags, and you can either go to climate here, climate, where it is, climate. There we go, there you can see there's 89, climate change. You can go to climate there, and it will give you all the data sets, and then you just basically run for this and find the one of your interest. Okay, so there's leaf area index, there's land surface temperature, there's the TerraClimate. You can see there it sits there. So there's different ways to get to the data set. As I said, you can go view all data sets, you can browse by tags, or you can simply search for it. Okay, so now that you've got your data set, okay, so let's have a look at the data set itself. Okay, as I said, it is monthly climate data, so that's my first interest. It's monthly images, monthly data, ranging from 1958 to 2022. So that gives you 42, 64, almost 65 years worth of data. So 65 times 12, you make the calculations, it's almost 800 images or data set points. It's the provider is University of California. There is the unique identifier of the data sets. You can see it's either TerraClimate. It's an image collection, obviously, because there's multiple images there. That's probably what's close to 800 images and counting. Okay, so you can go into the description of it. You can read through it. Okay, at the bottom, obviously, there's always our nice little code to get started with it. Okay, bands. This is the important part. Let's have a look at the bands. Okay, so it is 4,638 meters resolution. So that's most probably the only negative of this data set. It's very low resolution. So it's not like the land cover, which is 10 meters resolution, where you can drill into almost a very granular level. Here you almost it's quite a big area that you're looking at. So that's most probably the only negative of this data set. It's such a low resolution. So you can't go into a very small specific area. Be that as it may, here's all the bands or the variables that you can find in this data set, or the images. You can see it's actual evaporation, climate water deficit, Palmer drought severity index, reference evaporation. But if you look at the more at the bottom, the one that I'm interested in, it is minimum temperature, maximum temperature, vapor pressure, wind speed, and there's participation, accumulation, runoff, etc. So there's all the codes for the specific bands. So there's quite a lot of bands. You can see there's the units, and obviously minimum and maximum temperature is in degrees Celsius. You can see that. And then it's a minimum and maximum. But importantly, have a look at the scale factor. Okay, so it's always important to apply the scale factor within your code. Otherwise, you're going to have numbers that doesn't make sense. So for example, minimum temperature, you don't get a minimum temperature of minus 750 degrees Celsius. That is impossible. I mean, you won't survive. Or a maximum in that case of 387 degrees. I mean, that's very, very hot. You're not, nobody's going to survive that temperature. But remember, this is scale factor. So you have to multiply these values with 0.1 or with 10%. So therefore, the actual values is actually 77 and 38.7. So 77.0 and 38.0. 38.7. Now that makes sense. 38.7, that's not too bad. I mean, that's the temperatures that make sense. But 387 not. So remember, there's a scaling factor, and you need to include that scaling factor in your analysis or in your script. Okay, and as I said, at the bottom is your normal script to get going off. And in this case, it's the image collection. The filter dates is for 27 for that specific month. And then they're selecting the TMMX band, TMMX variable. And let's have a look at TMMX. That is temperature maximum. So they're selecting the temperature maximum. Remember, they're not scaling it. So that's why it's minimum 300 to maximum, minimum minus 300 to maximum 300. But it actually should be minus 30 and positive 30. We need to apply the scaling factor. And then they've got the color scheme, the palette. And again, we can find out what those colors are in Code Editor itself. The map center, and you add the map. So that's the beginning, but this code should now look familiar in that you always call up the image or the image collection. You specify your dates. You filter for the dates. Then you filter for your region of interest. You identify the band that you want to work with. And then if there's multiple images in your time period, you apply a reducer, which is a statistic like mean, median, and mode, for example. Then you generate your visualization parameters, and then you center your map and you add your image or you add your layer. So that should be now standard practice. You should know that. So this is exactly what's happening there. Remember again, your variable name should be unique to your calculations or parameters. There shouldn't be any duplicate variable names in your script. And then you just press simply open code editor. So I'm opening the code editor, and there is my standard code. Okay, there's my standard code. So what I normally do is I take the standard code and I start working with this code. Okay, and I start working with the code. So the first thing that I normally do, let's just make this a bit bigger. Remember, the first thing I normally do is to add my assets. Okay, my region of interest. So that's what I normally first do. Remember, just move it a little bit. Our region of interest. Our first region of interest that I'm going to do is the district that I'm working with. So because this is such a low resolution, I'm going to expand the size of my area. Remember, we used to work with only a very small area around a specific town because we worked with very high resolution, and therefore it makes sense to focus on a small piece of or small region of interest. But here, with such a low resolution, working on a very small region of interest is counterproductive. You're not gonna, it's not really worthwhile doing it. So I'm going to increase the size of my region so that it fits the resolution of the data set. So that's quite important or meaningful. Your region of interest, the size of the region of interest should be proportionate to your resolution. So the higher the resolution is, the smaller your region of interest. The lower your resolution, spatial resolution is, the bigger the region of interest. Okay, so in this case, I'm going to go to my assets, and I'm going to load there's two files that I'm going to load, or two layers that I'm going to load. I'm going to load the shape file, which is the layout of my region of interest. And then I'm going to load also this one, the points one, which is random, I think 200 random points. But anyway, we'll shall see it. Okay, so first of all, I rename this my Roy, and this one I'm going to rename Roy points. Okay, again, what you call them, what your variable names you give them, that's totally up to your discretion. Okay, so that's the two things that I first do. I load my two regions of interest. One is just the broad outline of my area, my region of, and the second one is my points. And why I download the points, that will become clearer. Okay, so I haven't run this code or done anything. I'm just loading my assets. So the second thing that I'm going to do now, once I've loaded my interest, is to display my regions of interest, meaning add these two things to my layer. So when I run it, it will display that. And then going to center my map, and then going to clip my for my region of interest. Okay, so I'm going to add this code. So I've already done that. So let's close this one. But I said, you just go to code editor, press it, and then, as I said, I load my region of interest. Once I've loaded my region of interest, now I'm going to add my initial code, which is standard practice, which is add these regions of interest to my map, to my layer, so I can see where they are and how they look. Then I'm going to center it. So when I press run, it automatically the layers or the map centers around my region of interest, and I'm going to generate my clipping tool so that I display the images only for my region of interest. So that's standard practice. So I've already done that. So let's have a look there. So I'm going to close this one. I'm going to go leave, and here it is. Okay, so there it sits. Nothing different to what I've done previously. So I said I've loaded my region of interest via assets, and I've named them. Okay, then I'm going to add my two layers. Okay, so just map add layer. So I'm going to add my Roy, this one here, which is my broad outline, my vector file, giving it a color, giving it a name. And then I'm going to add my points layer. Okay, so this is I think it's 200 points. Let's have a look and see what that looks like. Nope. It's 200. I think it's 200 random points, but we're going to get to this a bit later, but I'm just loading it for now. So then I'm loading those two to my layers. I'm displaying it. I'm centering my map around my region of interest. And if you don't know how to get the coordinates, remember these are long and lats. That's my center point. You simply just go to add a marker and select it there, and then derive the codes or derive the centroids for that specific area. And remember that your 8 is your zooming factor. I think it's between 0 and between 1 and 24. Remember, the higher that number, the more you zoom in, and vice versa. And then there's my clipping tool. Okay, so I'm going to clip all my images around my ROI, which is this one here. So that's my clipping tool. So I said these are standard practice. Okay, adding these codes and adding my assets. That's standard. Okay, so now what I need to do is I need to save. Okay, so I'm going to go to save. I'm going to go to this little drop down menu here, and I'm going to save with the description. Okay, and there it goes. So I'm going to call that TerraClimate .1. Okay, so that's what I'm going to press OK. You see there my new scripts. It should now give you the name of that script. There we go. And if you go to scripts, here you can go down, scroll down. There it says Terra. Let's make it a little bigger. You see there, TerraClimate. So I have now saved my script. So every time I want to go back to it, I simply just go to script, scroll down to this, and then just double click on it. And it will load. You'll see it will automatically load. Okay. So now I've saved it. You can see it's blanked out. So that means it's been saved. Every time I do something new, it will highlight itself again and then just save again. Okay. So what's the next steps? Once I've loaded my assets and I've loaded my layer, centered it, and generated my clipping tool. Once I've done all this, now obviously I need to generate my images. Okay. So again, remember, nothing strange. I've got my image collection with its unique identifier. So there's my image collection with unique. So in this case, I'm going to select the maximum temperatures. Okay, and then I filter for my date and clip for my region of interest. And I give it a name. Let's do this for now. I give it a name, dataset pre. Now, you could call it anything. So I could call it max temp 1960 to 1970 if you want to. That's up to you. So these variable names are totally up to you. That's up to your discretion. But just keep it simple, keep it straightforward, not too elaborate. Yeah, just keep it very plain and very simple. So what I want to do is, remember this data set, we go up, is from 1958 to 2022. So I don't want to, I want to, and then again, this is up to you. That's your choice. But what I want to do is I want to generate a beginning period and an end period. And then I want to compare these two periods visually. Okay. So that's what I want to do. You can generate one image for the whole data image collection. You can generate multiple. That's whatever you want to do. That's totally up to you. The method stays exactly the same. So you can play around with it. So what I want to do is to say I want to generate a image for this decade, the 1960 to the 1970 decade. There's 10 years. So that will give you month 120 images. So I don't want to use just one particular year, because that year could be an extraordinary hot year or extraordinary cold year. It could be some anomaly, etc., etc. So that might skew my analysis. So I want to create a single image for the first decade. Then I want to create a second image which would be for the last decade. Okay, so then now I have an image for my first decade, 1960 to 1970. Then I will have an image for my last decade up to present, and then I can compare it. And why I'm using decades is 10-year intervals. That's just arbitrary. Again, that's totally up to you. But I'm not going to use a single yearly image, because that could be an anomaly year. That could be an extraordinary hot year or extraordinary cold year, as I said, which may confuse my analysis. Okay, so there's my unique identifier set, and I'm select maximum temperatures. Now the TMMX, where do I get that? I go to bands, and maximum temperature is TMMX. So if I want to use minimum temperature, I will use TMMN. So I'll just change that to TMM. Okay, so changing the band is quite simple. You just change the band details in this piece of code. Okay, so I'm going to my image collection. I'm selecting my band, I'm clipping it for this particular interest period, and then I'm clipping it for my region of interest, and I'm giving it a name which is called dataset pre. Okay, and I'm doing a second one, backspace. I'm generating a second image which I called my post image. Then same data set. I'm still selecting the same band. The only difference is here I'm filtering it for the latter decade from 2012 to 2022. So the last 10 years. So there's the first 10 years and there's the last 10 years. And for both I'm looking at maximum temperatures and I'm clipping it for my region of interest. Okay. But now remember what is important. It's important that you apply your scaling factor. Otherwise you're going to get numbers, or in this case degrees Celsius, like 400 degrees or 200 degrees, and that's just impossible. That's not going to work. So for accuracy, we have to generate a scaling factor. We have to scale our values. And so this is what we're doing in this piece of code. I'm actually taking that image collection, that images in that period. Okay, so there is 10 years times 12, 120 images. So I'm taking all 120 images. Remember, I'm getting that data set pre. Remember, what is data set pre? Is this part here. Is that 120 images? So there's 120 images, and I apply a scaling factor, meaning I multiply the images by 0.1. Okay, so that is what I'm doing there. I'm taking all this 120 images that's now under this variable. Remember, this variable is 120 images. Maximum temperature images clipped for my region of interest for this period. And so I'm taking all that images, which is basically what it says here, and I am multiplying those images by a scaling factor of 0.1. And I'm giving those scaled 120 images now a new variable name, which is dataset pre1. Okay. Remember, the scaling factor is in here. So to understand by the scaling number, you just basically go into your landing page and you just basically use that scaling factor. So in our case, it's 0.1. So I've got now 120 scaled images, scaled clip maximum temperature images for this period. Now I'm going to reduce it to one singular image for that unit using my median statistic. Now again, you can use mean, maximum, mode, minimum, whatever statistic your heart desire. But as I said in many of my previous tutorials, the medium seems the most appropriate. But again, that's up to you. That's up to your discretion. Play around with it. Have a look. See what happens. Whether the results are significantly different from one another or not. Okay. But anyway, so you can generate standard deviations as well, which we can do. Yeah, there's a whole lot of reducers that we can apply. Okay. But anyway, so let's have a look. So understanding the code, I am generating images, monthly climate images in this image collection. Now specifically looking at the maximum temperatures, and I'm looking for this period and I'm clipping it. So therefore this data set pre will have 120 monthly maximum temperature images clipped for my region of interest spanning 1960 to 1970. And then when I take this 120 images, I'm going to multiply each image by a value of scaling value of 0.1 to get to the accurate numbers or the correct units, minimum and maximum units. And then I am applying a reducer, a medium reducer, to generate one image for that period. Okay, so this data set pre-image, this one here, that is a single image, which will be a median image of this 120 scaled maximum temperature images for this period clipped for my region of interest. Okay. And what I'm doing secondly, I'm just doing it for my post period. So post period is just from 2012 to 2022, mapped, same argument, same philosophy, same methodology. I clip it, and then I generate a mean. Okay, so here is I'm generating a singular scaled medium image for maximum temperatures for my two decades, the initial decade and the pre-decade and the post-decade, the pre and the post. Okay, so that's what I'm doing there. And I said I'm clipping it for my region of interest. My region of interest is this west coast boundary or a layer. Then I'm generating my visualization parameters. My minimum is minus 30 and my maximum is 30. Remember, that's my scaled numbers. If you go into the landing page of it, you'll see it will be minus 300 and positive 300. I've made it 30 and minus 30 and 30 because I've scaled it by its scaling by its factor. Okay, so it's scaled. There is the color scheme, the palette that I'm doing it. If you want to have a look what they are, remember, we just go to, let's say, draw a rectangle, just to open the geometry. Remember, then I press on the nuts here. Okay, that will give me this, and then I just basically, okay, let me copy that first. I copy that one there. I go to geometry, I click on nut, and I paste it in there. And it gives me this bluish dark blue color. And if I do the last one, I go to copy this one, go to nuts, and I paste it in, so that gives me dark red. So just by looking at the initial value and the last value, this is dark blue and this is dark red. So this will be from dark blue going all the way to light blue, and then moving into light red, going to dark red, something to that. So that's sort of the color scheme that it's going. So minimum temperatures will be blue and maximum temperatures will be reddish. So that seems to be the color scheme. Again, you can change it. And then I'm simply just adding these layers to my map, and then I'm generating an export function for each of these images. Okay, so I'm adding the median scaled initial image, and then I am adding the median post scaled image. I'm applying to both of them this visualization parameter, which have this minimum, maximum, and color scheme, and I'm giving it a name. Okay, that must actually be 2012 to 2022, and then I'm giving it a name and I'm giving it an export. Okay, so I'm exporting this one and blah blah blah. Okay, so very basic code. So in terms of that, let's click on run, and basically what should happen is there should be 4 layers added to here, which is my region of interest vector, my region of interest points, my first decade medium scaled maximum temperature image, and my post last decade medium scaled maximum temperature image, both clip for my region of interest. So that's the 4 that I'm gonna load. Okay, so if I make this bigger, and you see, voila, there it sits. There's my 2. Okay, so let's first go there. There's my region of interest. You can see it's quite a large area, and this is normally the region that the area that we initially looked at with very high resolution images. We just basically focused on this part of my region of interest. Now with this very low region of interest, low spatial resolution, I've expanded my region of interest to include this whole area. Okay, there is my points. You can see I think it's basically 200 random points generated in this region of interest, and the reason for this will become clearer a little bit later. For now we can simply just ignore it. Okay, so there's my call it first decade medium scaled maximum temperature image. Okay, remember, the more red, the higher the temperatures. Okay, the more blue, the lower the temperatures. So this indicates quite high temperatures here in the middle of this area here, very high temperatures, and more and colder temperatures around this seaside here, and this is mountains. If I go to satellite, you'll see that is mountainous areas there, and that's most probably why you see there's a mountainous area. That's most probably why it's a little bit cooler, because it's on the mountains and closer to the ocean. It's a bit cooler, but in this particular area here, it's very, very hot. You can see it gets more and more hot as you go. Let's go from south to north and from east to west. Okay, so you can really see this is the major hot area, cooler areas around here. That's for 1962, 1970. Remember, it's a median image scaled. If I go to the last decade, if I look at that, if I overlay the two, you can see there, it looks like temperatures in all of the areas have increased, the maximum temperatures. Remember, the maximum temperatures. Now, maximum temperatures is roughly around 12 o'clock during the day. So that's roughly when you can give an idea of when the maximum temperatures, about 12 o'clock, 1 o'clock during the day. So you can see gradually the temperatures have increased, become hotter. The patterns are still the same, meaning cooler around the mountainous area and this part, and hotter around this part. So the trend or the pattern of maximum temperatures have stayed roughly the same, but it did seem like it's become hotter. Now that's, so let's just look at, okay, so let's go to my inspector and let's look at this particular location here. So I go to inspector, it gives me, my cursor becomes that cross, and I found a location, I left click. And what it will give you is, it will give you the temperature. So that was the temperature at that location. Remember, that was the median maximum high temperature, the medium scaled maximum temperature, which is basically 27.2 for the first decade, and that has increased to the latter decade up to 28.7. So that's a 0.5 degrees Celsius increase in 40 years, 50 years. Okay, so that's 0.001 increase per year. So that's a very small increase. Okay, so let's have a look at this. Remember, so that's the year, it's about 27, 28. Let's have a look at this particular location. If I click there, you'll see it's 21 and 22. So from this location, roughly a year, to this location is almost a 8 degrees Celsius difference. It's 8 degrees Celsius cooler, 8 degrees Celsius cooler here than a roughly about here. Let's say round it off 10 degrees. So that's quite a bit. And this is also increased by about, that's also increased to 21.5. So that is 7 degrees. No, 5, it's, so that's about 12 degrees. Yeah, about 12 degrees, 1.2 degrees, not 12, 1.2 degrees increase. So here's a 0.7 degrees increase, here's 1.2 degrees increase. This area is about 10 degrees Celsius cooler than this specific area here. So where it was very hot, it didn't become much hotter. It did get hotter, but not much hotter. Where it was more cooler, it became more hotter. And you can see the differences here. Let's have a look at this place, which is on the mountain. Let's have a look at that. You can see it's quite cool here, 19 and 21. So that's a 1% increase in Celsius. Okay, so it's quite neat. You can visually identify, or you can visually determine what has happened with maximum temperatures, and then using your inspector, you can actually determine the degrees and the change thereof for that specific location that you choose, etc., etc. So quite neat. Quick way of generating quite interesting statistics, but I said for me it's more important the method and applications of using this data set in code editor specifically, what we can do with the data set rather than the results of the data. So yeah, so this is just very beginning. Now, as I said, we can basically now just do the minimum temperature. So remember minimum temperatures, let's have a look at that. Remember the minimum temperatures are TMMN. So I'm just going to change this now to N and change this to N. So I'm keeping all of the rest the same. Remember the scaling factor is still the same. Remember the scaling factor is still the same, 0.1. So I'm leaving it. So I'm running it. Now you should remember to change the variable names. Okay, you should change the variable names. So let's just quickly run it. I'm not going to But yeah, please remember to change that. Okay, so let's have a look and see what this looks now. You can see first, the first thing is the color looks quite different. It's still struggling to load. Remember, it's quite a sizable area again, so you may run into timeout issues, um, depending on the strength of your internet and all these fancy things. Okay, so let's have a look and see there. It's starting to load, struggling to load. Okay, so while we're waiting, let's use the inspector. Remember, we had the inspector roughly around there. Let's see what the temperatures look like. 12 and 13. Remember, the maximum temperatures were around 21 and 22. Minimum temperatures around 12 and 13. So that's a 10-degree difference between minimum and minimum temperatures around 12 o'clock in the night. Okay, and you'll see the 0.9%, 9-degree increase. Maximum temperatures, I think, increased by 1.2%. So the nights have become hotter as well, less cooler, but the change was less than the maximum temperatures, and I think the other one was around here. Let's have a look at that one there. I think the maximum temperatures were close to 30. And you can see the minimum temperatures 10 and 11, which is not too different from this. So the minimum temperatures looks fairly similar. Okay, so let's have a look and see. You can see there's not, yeah. So it's a bit lighter and this is a bit darker. But I think you get the hang of it in terms of generating, and you can generate, and our next one we're going to look at some of the other bands that we're going to play around. But I think for now, let's pause it here in terms of generating, let's do that, of playing around or starting our journey with this specific data set. And I said there's, given the dynamics of the data set, there's lots and lots we can do in Google Earth with that data set. Okay, so yeah, I hope and trust you enjoyed this this first video tutorial on this specific data set. And thanks for joining me on this remote sensing journey. I appreciate your company, and I hope you will join me for the rest of 2024. And please remember to like, subscribe, and to share the video, you know, all those fancy things. And I'll see you on the other side.